Okay, between easy and moderate. What about others? Compared to quiz one, it was better. All right. So for all of you, it was good. The exam.
Yeah, yes, ma'am.
All right.
Ma'am, I felt little difficult.
Sorry, can you repeat?
No, I felt little difficult.
Okay. So which part you found it to be difficult?
I actually went through all the activity questions and actually, well, that's how I prepared. I can't spend much time in doing everything. So what I did was by revising all the activity questions, graded assignments, practice assignments.
Okay.
I was not able to complete. I mean, I was not confident with even 50% of the answers. I, I forgot so many things.
Okay.
That's what I'm saying.
Okay.
I need some tips like how to get through the final exam because I know I'm going to get low marks and I was supposed to also. Because one also I got low marks, but at least I want to do something better in this final exam. Will it be mostly from the 9th, 10th, and 11th, 12th?
Yes.
Session?
So we'll be sending the like exam pattern by Monday.
Mhm.
So, yeah, it's mostly weak estimation part and hypothesis testing.
Ma'am, also, I didn't attend the mock test and all. I thought of putting it in the forum, but I forgot. Like, if we do the mock test, well, was that very useful for doing the
Yes, so
quiz?
it is always said like you do the mock always like because the pattern of the mock is very similar to what you get in the quiz paper generally like the weightage and what kind of question, the topics that it covers, everything you can like relate and like it's a good practice. So never skip the mock. Please do attend the mock.
Okay.
And any session like if you see the peer text slides, right?
Yeah, I do that. Yeah, but that helps me in doing the graded assignments part.
Not the graded assignment part. So the periodic slides that Professor Andrew has taken the session for.
Mm.
Uh, Please do attend solve those problems at least.
Okay, ma'am. Thank
Okay.
you.
Yeah. Okay, just give me a minute. All right. So now we will start with week 10. So I hope week 10 graded assignment you all have submitted. So how many of you have still doubts in week 10?
Yeah, I have.
Okay.
Ma'am, I didn't do the assignments. I think I was the one who put in the discourse forum asking for more explanation in the
Okay.
weekend topics.
Okay. All right. Okay. Yeah. So we'll start with the very first act like lecture of week 10, and then we'll just first see the theory part for the hypothesis testing and all the tests. Then we'll move to the question if you have any doubts. Okay. Quiz 2 results will be announced maybe by Tuesday, Wednesday, something. Cannot say for sure now. Yeah, okay. So I will share my screen.
So are you taking week 10 only or week 10 and 11?
Both
Because
week 10 and 11.
and 11. Okay, fine.
Yeah. So I will cover the theory part and then we will move to the questions. All right. So the first thing that, okay, this is for hypothesis testing. So the first thing that we have to learn here is like how to decide what is your null hypothesis, that is H naught, and your alternative hypothesis, that is HA. So null hypothesis is generally the statement or the fact that we always believe to be true. So like if you have to, let's say you want to check whether the height of students in a class is greater than something or not. So let's say you believe that the average height of the students is, let's say 160 centimeter, but you think that it is low and you take an alternative hypothesis that you want to check that height is average height is less than 150. So I'm saying is like what I believe is that the average height mu is equal to 150 centimeter, and if it is believed that it is lower, so I will take an alternative hypothesis which says mu is 150, and we want to check this claim whether this is less than 150 or not. So this is the general idea of the null and alternative hypothesis. So whatever you want to check, whatever you want to claim, you have some fact or evidence, you have the sample, and from there, whatever you wish to check, you take it as alternative hypothesis, and the simple hypothesis we consider as the null hypothesis. Then given the samples, you have to either accept the hypothesis or you will reject the hypothesis. I mean the null hypothesis. So there are two terms here. That is the type 1 error alpha. So probability of uh, probability of type 1 error, and type 1 this is considered as alpha, written as alpha, which is also called the size of the test. And the second part is type 2 error, so probability of type 2 error, which we called as beta. And there is a third term which is called as power, and it is given by 1 minus beta. So what is alpha? So alpha is the probability of making type 1 error. And what is type 1 error? It is like in case you know that H naught is true, like given the H naught is true, still you go and reject your null hypothesis. So by doing this, you are making an error that is called the type 1 error. So alpha is defined as probability of rejecting your H naught given your H naught is true. So you knew that like it was okay, so it was like your null hypothesis was true, but still you have obtained the sample. On the basis of that samples, you have calculated your test statistic, and from there you have rejected your H naught. So by doing this, you are making an error, and that we call as type 2 error. The second term that
Excuse me,
yeah.
ma'am. Here only I had the doubt first.
Okay.
We are taking a sample, and that sample was termed as acceptance test sample, correct?
Uh, what
that
is
was
acceptance test sample? I think you want to know about the acceptance set.
no, that was taken, and then only we started doing the type 1 error, type 2 error. We are saying rejecting H naught.
Yes,
A
yes.
is a set of samples, and then I say rejecting is A complement. I had a doubt in that term. When I say acceptance test, I'm saying this is correct, no? Then why again I'm saying I'm rejecting it. I got confused with that term. The test, the sample is, we have to just assume it's just a sample that I've taken. There may be multiple things, but I just took a sample. And in that sample, when I applied my logic, I found it's H naught is wrong. So I rejected, even though H naught is true. Is that how that I have to take consider that?
Yes, like let's say your H naught is true, isn't like say I'm saying my mean is 150, right?
No, okay. This example.
So I know that my mean is 150, but still you go like you have obtained the sample and on the basis of that sample, you have a test statistic value, and using the critical, whatever critical value you get, on the basis of that, you reject H naught.
Say,
In this
okay,
case,
so I'm assuming, say there are 100 students in the class and already the mean is taken, it's 150. That's what it means. H naught is true. The null hypothesis is true.
yes.
Mu is 150. But I took a sample of, instead of 100, I didn't take the entire population, I took a sample. Say, for example, I took 20 students and I found the average height of them. Of course, the average cannot be the same as 150. So I found it is 140 or something. So I'm rejecting the H naught, correct?
Okay. So what you got your X bar to be 140, right?
Yeah, I got 140 in my sample. Yeah.
Huh. So, but your C, what is your C there?
I didn't understand from there because okay, C, I don't know what C is here. C is 10 because
Yeah.
it's
So
difference.
C is the critical value, like the value at which, like after that, you will accept or reject the null hypothesis. It's
Okay.
like I will come to that part.
No, okay, ma'am. Okay. No, I just had the doubt because the word was used as acceptance testing. I'm taking the sample because I accepted it or something. No, no, it's not
So,
like that. It's like
okay.
just I took a sample. That's all.
Yeah, so there was one example that has been done at the beginning of the week, lecture 10.1. So there you have, let's say you are tossing a coin 3 times, right? So what are the possible outcomes do you have? You have HHD, you have HHH, HHD, HTH, HTT, up to, let's say, TT.
Eight outcomes. Yeah.
So there are total 8 outcomes, right?
Yeah. Okay.
Now, in this case, this is your script X, right?
Yeah.
So
All
this
the
was, no, this was script XQ. Okay.
Mhm.
So any subset of this you take. So any A that you take the subset. Okay. So that is your acceptance set. What I'm saying.
Oh, okay.
So
Okay.
you pick one subset from there. Let's say I pick our subset to be, let's say HHH. And from this sample, I want to check.
Okay.
So there are the total number of possible set that you can get is 2 to the power 8, right? Total number of subsets.
Okay.
So that is
How we will get 2 raised to power 8 subsets from this?
you have studied set theory, right?
Yeah.
So
One
if you
element,
have a
two
set,
elements, three elements.
yeah,
It can be
if you have a set, let's say A, B, C, D. So total number of subsets that you can get from these 4 elements is 2 to the power 4, right? Like the let's look at the smaller example. So let's say if I have AB, how many subsets you can have? One is like just 5 null set, other is the singleton A, other is singleton B, other is AB. So for 2 elements you have 2 to the power 2, right? If you have 3 elements in the set, let's say A, B, C, you will get 2 to the power 3, that is 8 subsets, right?
Oh, okay.
So now we have here 8 elements in this set, that is script X cube. You have 8 elements. So A is any subset of this script X cube, right? So the total number of subsets that you can get is 256. So you will check for each of the sets and like look for the alpha and beta. We always want to minimize our alpha and beta, type 1 error and type 2 error. Okay.
Yes,
so so alpha was defined as, so like alpha was defined as probability of rejecting your H naught given your H naught is true. Like even though H naught was true, you have got a sample, and on the basis of that you are deciding that you will reject H naught. So by doing this you are making an error. So we want to reduce that error, and that is called significance level. And the other term is beta, that is type 2 error. So this is given by probability of like given your HA is 2, given your alternative is 2, still you are accepting your H naught, right? So when your alternative was true, and when your alternative was true and still you are going and accepting your H naught, by doing this also you are making an error. So we want to reduce this error also. So we have to choose such alpha for which your beta, or let's say the power that is given by 1 minus beta. So you always choose such alpha for which the power is maximum. And if the power is maximum, your beta will become less, right? So we want, there is some trade-off between this type 1 error, that is alpha and power. Now there are three different tests that we are going to study again and again in all the lectures.
Nikita, may I ask a question?
Yeah, sure.
Is there, I mean, we have studied in the lectures that we have to calculate basis the value of C. All the computations are done basis the value of C.
Hmm.
I just want to know, is there a way where we do not involve C and still can do the calculation?
Yes, p-value, right?
P-value, yeah, okay, fine.
P-value approach.
Okay, and we'll be
So
discussing that also, right?
yes, that is
Yeah,
why p-value is a little easier concept.
yeah, okay.
Okay.
You'll be taking it also in revision, right?
Yes.
Yeah, okay, fine.
Okay. So there are two type of hypothesis. One is termed as simple hypothesis, and the other is composite hypothesis. So what do we mean by simple hypothesis? As any hypothesis that specifies the distribution of the samples. Let's say my sample X follows the normal distribution with mean mu and let's say variance 4. So if I know that, if I give that mu equals let's say 0. So now I know the distribution of my sample, that is X is normal 0, 4. So this such type of hypothesis become the simple hypothesis. The other thing is the composite hypothesis, where it is not completely specified like what is the distribution of the sample. Let's say the same example where X is given as normal mu variance 4, and I say mu is something that is greater than 0. So here I don't know clearly what my distribution is. The mu can take any value. So such kind of cases, such kind of hypothesis is called the composite hypothesis. That we generally take as alternative hypothesis, right? So null hypothesis is always the simple hypothesis, and composite we take as an alternative hypothesis. Now there are few tests that we will looking at. So one test, the first test that we are going to look at is Z test. Second is T test. Third is chi, uh, chi-square test. Fourth is two sample Z test. And fifth is two sample F test. So before going to the test, we will look at, let's say, okay. So the Z test and the T test, these are the tests for mean. These are the tests for mean. And there are three different cases. So one we call as the right tail test. The right tailed test. Next is your left tail test. And other is two-sided test. So given your null hypothesis, let's say my H naught is mu equals mu naught. So what is my right tail test? Write it here. So H naught is mu equals mu naught. So what is my right tail test? In this case, your alternative hypothesis is going to be mu is greater than mu naught. In case of left tail test, your alternative is going to be mu is less than mu naught. And in case of two tail test, your alternative hypothesis is going to be mu naught equals to mu naught. So we will look at all these three examples, like how to solve such kind of problems when we look at the problems. Okay. So the first test that we have is the Z test, right? So this test is for testing the mean, right? So we assume that the samples are normal and variance is known to us in case of Z test. So what we do here is, like, you have, let's say, x1 to xn, they are IITx. Expectation of x is given as, let's say, mu, and variance of x is given as sigma square by n. Now, there is a term that is called test statistic. So what is test statistic? Test statistic is any function of the samples. So this is any function of the samples. So you can, we denote generally this by capital T. So this T can be either, let's say, x1. Our samples here are x1, x2, x3 up to xn. So one test statistic can be x1 plus x2 plus up to xn. Other test statistic that we can consider is x bar, sample mean, right? Other test statistic that we can consider is our sample variance. So since this is now here we are talking about the Z test, so we'll just look at these two test statistic. Okay, this will come later. Look at later when we talk about the test for variance. So test statistic is any function of the sample. So you have a sample, and using that you calculate the test statistic, and on the basis of that you just decide whether you will reject your H naught or accept your H naught. So when I look at the right tail test, so let's say I'm saying my null hypothesis is mu equals mu naught. Alternative hypothesis is mu greater than mu naught. Now I have these samples x1 plus x2 up to xn that are IIDx. Let's say I am taking my test statistic, that is T, to be x bar, and I will reject my H naught. Now my test is, I will reject my null hypothesis if my test statistic is going to be greater than some critical value C. So if I have, let's say, mu naught, that is H naught. So around this, we have a normal distribution. And for any mu that is greater than mu naught, let's say this is our C. If the test statistic value comes out to be greater than C, we will reject my H naught. So this is our rejection reason. This we call as rejection reason, and this we call as acceptance reason. And this is your distribution of P. This is your distribution of t. So t in this case is what? This is x bar, right? So t in this case is x bar. So distribution of t is going to be normal with mean mu and variance sigma squared by n, right? Because this is sample mean. So, okay, this is my test. So if I have to calculate alpha, that is probability of type 1 error, what will I do is, I will find probability that reject H naught given your null is true. So null is true is mu equals mu naught. So when I'm going to reject H naught, if my t is greater than c, if my test statistic value t is greater than c, we are going to reject my H naught. Now this t is x bar, so x bar minus, I can convert this t to this normal 0, 1 form. So we'll get the z and we can calculate the alpha value. So t was x bar, and if I subtract the sample mean expectation of x bar from x bar, so that is mu, and mu is given as mu naught. And if I divide the standard deviation of x bar, so what is the standard deviation of x bar? Variance of x bar is sigma square by n. So standard deviation of x bar is sigma upon root n. So sigma upon root n. Same thing we'll do on the right hand side. So it is going to be c minus mu naught divided by sigma upon root n. Now I know that this is normal 0, 1, that is z. This we can write it as 1 minus f z of c minus mu naught upon sigma upon root n. So we already, so here mu naught is known, sigma is also known to you, and n is given to you. So once you do it, you can find your alpha value. You can find your alpha value. So you can find your alpha value only in the case if your c is unknown. So what we, yeah.
Sorry, ma'am, sorry to interrupt. Actually, in activity question number 6, I think it's in the tutorial, I mean, in the session 2, we did this some examples with some examples. There, I think it was given as consider 50 samples with normal mu and 2, I think, and the H naught is mu is minus 0.5 and HA is mu is equal to 0.5. This is question number 5 and 6 in activity week 10, activity 2. So there, what doubt I have is similar to what you did. We converted to normal 0, 1. By converting, I take the t is acceptance is t is less than or equal to c, but alpha is t is greater than c when mu is equal to minus 0.5. So what I did is while converting, I added a plus 0.5 so that it became a 0. And similar to this, we have written minus 0.5 comma 1 by 50 plus 0.5.
Okay, I'm not able to understand what you're saying. So after I'm done with this part, I will go back to activity 10.2 and I will look at the problem.
Okay, ma'am, sure.
I have written it down here, so we can go back and look at this problem.
Okay. Thank
you. So what we always do is, we fix our alpha because we want our alpha, that is probability of type 1 error, to be as less as possible. Generally, people like take alpha as 0.05 or 0.01, like this is a general convention. So first we fix our alpha. Let's say I'm fixing my alpha to be 0.05. I'm taking my alpha to be 0.05, and using that alpha, I want to given this alpha, I want to find my critical value. So what is this alpha? So let's say if this is your critical value, this for, let's say for this alpha, for some alpha, you are getting C. And this alpha, that is probability of type 1 error, is the shaded region. Okay. So for alpha, let's say 0.05, I am getting some C value. So once you know the alpha, you can like easily find the C value, right? So this is going to be fz inverse of 0.95 sigma upon root n plus mu naught. This way you can find your alpha. Now, the same way you can find your type 2 error. So what is type 2 error? Type 2 error is beta, that is given as probability of probability that given your HA is true, given your HA is true, you are accepting H naught. You are accepting H naught. So if I had the right tail test and I was rejecting H naught if T was greater than C, right? So I will accept my H naught if my T is less than equal to C, given H naught to be true. So HA to be true. So what was HA? Our HA was mu is greater than mu naught, correct? So whenever you have to find the type 2 error, your distribution for the alternative hypothesis should be known to you. So there will be some value that mu naught is taking will be given to you whenever you will have to find the beta. Okay, so let's say for some mu naught dash, I have to find, I have to calculate this. So this is going to be mu equals mu naught dash. So given your alternative is true, you are accepting H naught. So the same way we have converted this to the normal distribution form, we can do the same thing here. So probability that Z less than equal to C minus mu naught dash divided by sigma upon root n. And this is nothing but fz of C minus mu naught of dash divided by sigma upon root n. So if my alpha was given to be 0.05, then my C will come out to be fz inverse of 0.05 sigma upon root n plus mu naught dash. So we always try to like take such alpha for which your beta is always less. This is how we find the probability of type 1 error and type 2 error. And if you have to find the power, you will find just 1 minus beta. That is probability of rejecting H naught given HA is true, right? So this is nothing but probability T is greater than C given mu equals mu naught dash. Yeah, you can try it out. So it's the same way, same procedure. You can find the power. Similarly, you can do for the left tail test. So left tail test, I'm not going to do it here. I will just directly go to the right tail test. Sorry, two-sided test.
Nikita, in the graph that you have made,
Hmm?
if you can just scroll up,
Yes, yes.
can you tell what would be alpha and beta and 1 minus beta in respect to this particular graph?
Okay,
Alpha would be
so
this particular region, and that
okay,
is the
wait.
rejection.
So
Okay.
there is something I can show you. Just hold on. Okay, so this is one GeoGebra applet. So let's say this is our null distribution. Okay, the blue normal curve that you're seeing here is your normal like null hypothesis, null distribution. Okay, so this is the red curve here is my alternative distribution. So I can shift my new like alternative hypothesis, and my distribution also will shift accordingly, right? So let's say I fix it at, let's say 2.2. Okay. Now I want to find the type 1 error. So type 1 error is what? It is probability of rejecting H0 given your H0 is true, right? So the blue curve here is a this distribution, null distribution, right? So this is for your mu naught. So given this mu naught is true, you are rejecting your H0. So if I click here, you can see that this blue, this yellow shaded region here is a type 1 error, that is alpha, and it is 0.31. So as I move my critical value, so see here is my critical value. As I shift it, let's say I am when it is at 0, my alpha is more, right? As I keep moving it, like as I'm increasing my C, my type 1 error is reducing. Correct? Now, if I have to find the type 2 error, so type 2 error is for the given alternative distribution. So my alternative distribution is the straight normal curve. And given that your alternative hypothesis was true, I'm still rejecting my I'm still rejecting my alternative hypothesis. I mean, we are accepting the null hypothesis. So if I go and click it here, this comes out to be my type 1 error, that is 0.27. So this is how it will look like. I will send this GeoGebra applet. You can download it. You can make an account on GeoGebra and you can edit few things and try to see like how it works. Okay. All right. So similarly for the left tail test, you have H0 to be mu equals mu naught and HA to be mu is less than mu naught. I am taking my test statistic to be X bar, and the test is reject H0 if T is less than C. So similarly, you can find your alpha, you can find your beta, and you can find your power. The same way we have done for the right tail test. So the next is your two-sided test. It is a little different. Two-sided test. So in this case, my null hypothesis, that is a simple hypothesis, it is given as mu equals mu naught, and alternative hypothesis is mu not equals mu naught. Okay. And okay, so if my test statistic is, let's say, X bar, if my test statistic is X bar, I will say my test is reject H naught if mod of X bar minus C, sorry, mod of X bar minus mu naught is greater than C. So why we are writing this, if I make a normal curve around mu naught, so this is a distribution for X bar, right? It's a distribution for X bar, and X bar minus mu naught greater than C. So in case of two-sided test, you have two tail here, and these two combined will be your alpha. Okay. So if you look at it, if you look at this expression, it will give you these two areas. So once your sample, the test statistic value, if it is greater than, so if you just open it up, you will get X bar minus mu naught greater than C, that is X bar greater than C plus mu naught, and minus of X bar plus mu naught greater than C, that is X bar minus mu naught less than C, that is x bar less than C plus, something is wrong, not plus, okay, minus C minus mu naught. Yeah, so x bar less than mu naught minus C. So this is your mu naught plus C and this is your mu naught minus C. So once your x bar is greater than mu naught plus C, you will reject H naught, and your x bar is less than mu naught minus C, you will reject your H naught. And these two combined will give you alpha. That is type 1 error. So if I have to find my alpha, it is type 1 error. That is probability that you reject your H naught. So that is x bar minus mu naught greater than C. Okay, this is mu. So mu greater than C, given mu equals mu naught, right? The same way you can do it here. So x bar minus mu naught divided by sigma upon root n. This is again C minus mu naught upon sigma upon root n. And this becomes probability of mod of Z greater than C minus mu naught upon sigma upon root n. Now this is mod of Z, right? So
Hello, ma'am.
yes,
You wouldn't do C minus mu zero, right? Because it's already there.
which one?
Second step. It will be only division by sigma root n at the C side.
Oh, all right, yeah, yes, yeah, thanks. Yes. So it is right, C upon sigma upon root n. Here also it is C upon sigma upon root n. So Z here is normal 0, 1. So in case of normal 0, 1, this is like, you know the values, right? So Z is greater than C upon sigma upon root n and minus of, like Z is less than minus of C. This is minus of C sigma upon root n and this is C upon sigma upon root n. So what I can do is I can find probability Z less than minus C upon sigma upon root n. That will give me this area and I can do 2 times. So since I know that these two are symmetric, like normal distribution is symmetric about the mean. So this area will be equal to this area. So I can just do 2 times and we can find your alpha value. So it is going to be 2 times f z of minus C upon sigma upon root n. Okay. So any doubt in Z test? Like once you understand the Z test properly, like all the tests are very similar. Everywhere you're doing the same thing. You have a left tail test, you have a right tail test, you have a two-sided test. And the process is exactly the same. You always have to identify your null hypothesis, you have to identify your alternative hypothesis, you have to take some test statistic, and on the basis of that, you decide your test and find alpha and beta. So any doubt in this?
No, ma'am.
Okay. So the next topic we have here is p-value approach. So
Ma'am,
what?
before this, can we see that example? Sorry, I think this will be a new topic.
Okay.
The activity question.
All right. Yeah, that can be done. So you had told about 10.2 Question number 5, 6, right? Okay. So should I do the same 10.2, question number 5, 6?
No, I just had that one doubt, like how the denominator became 1 by 5. I was thinking the previous example, which Professor Andrew took was 100, and I thought it was the square root of 100 is 10. But here the samples is 50, the square root of 50, I thought square root of 50 should come back. And
Okay,
the solution, it was 1 by 5. I was
right.
not.
So it is AQ AQ 0.2, question number 5. Can you mute yourself for some? Yeah, so we have 50 ID samples. So X1, X2 up to X50, that is normal IID normal mu comma 2. Our null hypothesis H0 is given as mu equals minus 0.5 and HA to be given as mu equals 0.5. Now I am taking my test statistic T, that is nothing but X bar. And the test is you reject your H0 if T is greater than C. So again, it is a right tail test, right? You have to find what is the significance level of the test. So alpha is probability of rejecting H0. So rejecting H0 is T greater than C, that is X bar greater than C, given mu naught is true, that is mu equals minus 0.5. So if I convert it to probability X bar, minus of minus 0.5, right? So it is plus 0.5 divided by the variance of X bar. So what is variance of X bar here? Sigma square is given to be 2. So variance of X bar is going to be sigma square by n. And what is sigma square? 2 upon 50. So I will divide this by under root of 2 upon 50. Right? And this is greater than C minus 0.5, that is C plus 0.5 divided by under root of 2 upon 50. And this becomes 1 minus fz of C plus 0.5 divided by root 2 by 50. What is the answer for this question?
Actually, alpha is 1 minus fc of 5 into c plus 0.5.
1 minus fc of 5
Into c plus 0.5.
C plus 0.5.
No, well, I thought I did something different is in your alpha, finding alpha, acceptance test is t is less than or equal to c, so alpha is t is greater than c, that's fine. So when I normalize it, what I did is norm n minus 0.5, 1 by 50, plus 0.5, that's, I just followed the steps scroll by step, plus 0.5 divided by 1 by 5. That
1 by 5.
I didn't know how I got this 1 by 5. But if I put this 1 by 5, I get the answer. I was thinking it was 100, and so he made it as 10, so square root.
You did 1 by 5 because this 2 upon 25, 1 upon 25, right? and this becomes 1/5, right?
No, I don't get it.
See, what I did is I divided by variance standard deviation of x bar, that is 2/50. And 2
Okay.
upon 50 is 1/25. And if you do under root, you get 1/5.
Okay. Okay, that's it. Then,
Okay. So somebody had asked,
yes.
Ma'am, here we have to assume a low value for alpha and then look up the standard normal table, right?
yes, you have to look for the lower value of alpha and check the standard normal table, and so accordingly you find your C.
Okay, ma'am, go ahead, ma'am. I'm clear now.
Okay. Okay, so somebody has asked, like, in real world problem, if we reject null hypothesis, do we keep increasing its value till we accept null? So we don't actually do it. So that's why we fix our alpha. So we want to minimize our error, and we design a test such that our probability of making any type 1 error or type 2 error is less, and we design our test. So also, if you keep increasing the value of n, so let's say if my distribution right now is this, and my alpha is this value, alpha is this, and I have some critical value C for this alpha. So if I increase my value of n, my this variance will decrease, right? So you will have more this thing. So your variance will decrease and you have a slightly steeper curve. And in that case, our alpha will reduce, right? So initially our alpha was this blue shaded region, and now my alpha is this orange shaded region, that is less, right? So if as we keep increasing the value of n, our value of alpha, like probability of making any error, will reduce. So that's why we generally go for large samples in real life. So we'll move to the p-value. And so first we'll look at the definition. So what is p-value? P-value is the lowest level of significance at which you will reject your H0. So it is like you have some value of p. So given some t, so you have a test statistic for which you have obtained the value t, and the lowest level of significance, the lowest level of significance at which you will reject H0. This is what we call as p-value. So how we generally find it? So the process of finding the p-value is almost similar as finding the significance level. So in case of significance level, what we used to do is we used to fix some alpha. Using this approach, we used to fix some alpha, and we find our critical value. So we, let's say, reject H0 given H0 is true. The same way we find our p-value. So p-value is given by the probability of rejecting H0. So you have a sample, and using that sample, you have obtained some test statistic value. So if my test was, let's say my H0 was mu equals mu naught, and HA was mu greater than mu naught, and my test statistic was T, and I want to reject my H0 if T is greater than C. Okay. So again, in this case, in place of the critical value, whatever value you have observed for the sample. So let's say I am interested in knowing the fraction of some event. So if I have said, like, if I have tossed the coin 100 times, I obtain the head, let's say 55 times. Okay. So I toss the coin first time, I observed whether it is head or tail. Similarly, you toss the coin 100 times, and in total, I got my number of head to be 55. Okay. So this is what I have observed, and this 55, right? This 55 is going to be your T value, right? So T equals 55, the small t. Okay. So what is the test statistic that we can take? We can take this as sum of the samples, x1 plus x2 up to xn. So this will give you what? This will give you total number of heads that you will obtain, right? So reject H0 if T is greater than C. So T is x1 plus x2 up to xn. T is greater than this 55. Given mu naught is 2, that is mu equals, let's say it was 0.5, and this is greater than 0.5. So given mu equals 0.5. So this is how we find the p-value. In place of just critical value, you replace that critical value with the value of t that you obtain from the samples. And the process is the same in to calculate the p-value. What does the p-value say is, so if you have some normal distribution, you have some mu naught, and for some alpha, you have fixed your alpha, and let's say I fixed my alpha to be this. This is my alpha, I have fixed it. And for this alpha, my critical value is C. Now, if I get, if I do the test and I get my T to be greater than C, I will say I am rejecting my H0. If my T comes out to be here, I will say I am rejecting my H0, right? So, and let's say if I take some other alpha, let's say I'm taking my alpha, yes, okay. Let's say I'm taking some other alpha that is less than this alpha dash, that is less than this alpha. So let's say I'm taking this alpha, alpha dash. So this is my alpha dash, and for this alpha dash, you have C dash. Let's say this is the C dash. Can you mute yourself? Yeah. So for this alpha dash, you have C dash, and again, if you have this T, still this test statistic value, this T is coming in the rejection region. So we'll say we'll reject my H0. So once this observed value T, once this T equals T becomes equal to the critical value, we say once this t equals to becomes equal to the critical value, then that area that it covers is called as the p-value. So once this t, do it again. So once this t becomes equal to the critical value, this area we call as p-value. So this is the lowest significance level at which you are going to reject your H naught. And the way to calculate the p-value is just the same as you find your type 1 error. You just substitute your C as the observed statistic value. Okay. Any doubt in p-value?
So in this case, like in order to calculate C, we were taking the inverse of the significance value. Over here, we will take the FZ value of the formula that will form after normalization, right?
Uh, can you repeat again?
So in order to calculate what you are saying, it's the same.
Hmm.
Over here, we will take the FZ value. Earlier, we were taking the inverse, right? When we were calculating C, over
It's the
here,
same.
the FZ value will come directly,
Yeah, F set value will come directly.
right? Yeah.
Yeah, it's the
Okay.
same, almost same. Process is same. There we are fixing our alpha. We like in that case we
Yeah.
should
Yeah.
know what my alpha is,
Hmm.
right? And then we are finding my C. But here you can directly find the VP value and then this.
Ma'am,
Yes.
yeah, I have a basic question. This is not regarding to p-value. Basically, if I take t as just the sum,
Okay.
or and versus t as the mean, that is sum by n.
Sample mean. Okay.
Yeah. So then, I mean, how does it differ? Because sometime I'm
No, it won't differ. See, in this case, let's do this example. So I have said this, you have 100 samples that is coming from some distribution. Okay. You have tossed the coin 100 times and you have observed 55 hits. Now my null hypothesis is mu equals 0.5 and I'm saying my alternative is mu is greater than 0.5. I have to find the p-value, right? So the first case I'm taking my test statistic to be x1 plus x2 up to xn. That is going to be what? The binomial distribution, right? Binomial with n 100 and p 0.5. Now the test is
Nikita, you mean 0.5 over here to be the probability, right, of heads? You're taking
probability.
mu. You're
Okay,
taking mu as like the mean, or do you mean the
this is
probability of heads over here?
h not to be true. Okay. So
No,
whenever
no,
you
no. I'm
write,
taking in this H0. You have said mu equals 0.5. What do you mean mu 0.5 in this example specifically?
okay, it is probability of sorry, like expected value of getting a head in 100 tosses.
Okay, fine.
So x1 plus x2 up to xn will give you the total number of heads, right? And we know that each of the xi's are Bernoulli 1 by 2. If in case if it is an unbiased point, right? So what I've said is my t is x1 plus x2 up to xn. So it will be a binomial distribution with n equals 100 and I'm taking my h naught to be true, right? So the test is you reject h naught if t is greater than c. If I find the p-value, it is going to be probability of t greater than, so what is it that we have observed? it is 55 heads, right? So T is total number of heads and we have observed 55 heads. So reject H naught if T is greater than 55 given mu equals. So in this case, what is your mu that you will get? So mu that you will get is for the T, it is n times P, right? So 100 into 0.5, 100 into 0.5, that is 50. So mu equals 50. Okay? So probability T minus 50 upon sigma upon root n. So what is the variance? It is n times PQ. So 100 times 0.5 into 0.5, that is 25, right? So divided by 5, greater than 55 minus 50, that is 5 divided by root 5. And this will come out to be 1 minus fz of root 5. This is my p-value. Now, this is the p-value that we got when we consider t to be x1 plus x2 plus up to xn, right? Now, if I take my t to be x1 plus x2 plus up to xn by n. So this is basically x bar, and this distribution becomes the normal with mean p, that is 0.5, and variance p times 1 minus p divided by n. P times 1 minus p divided by n, right? So if I find my p-value, it becomes probability that x bar greater than c. So c in this case is just 0.5, right? This is what we have observed. Given mu equals
0.55, right?
sorry, yeah, 0.55. Yeah, right. So x bar minus, if you do it, you will get 1 minus fz of 0.55 minus 0.5 divided by what is this? This is 0.5, 0.25 divided by 100. So 0.25 divided by 100. And this becomes 1 minus subset of 0.05 divided by 0.5 by 10, right? Is there something wrong?
I think there it should be 1 minus fz 5, not root 5, because you are having 25 there, right?
Yes. Yeah.
Oh, yes, yes, right. Right, right, right. This is your 5. Yeah, might make sense. So it is 1. So you see, in both cases, we have obtained my p-value to be 1 minus fz of 1. So it all depends on what do you want to consider your test statistic to be. Is it okay?
Yeah, understood.
So after the p-value, we have uh, many different tests. That is t-test. T-test. That is also for testing of mean. Testing of mean. But in this case, our variance is unknown. Variance is unknown. So what we do is, whatever samples we have. So if I have x1 up to xn, IIT, IIT X, that is normal with mean mu and variance sigma square, where sigma square is unknown. Where sigma square is unknown. And I take my H naught null hypothesis to be mu equals mu naught and alternative hypothesis to be mu greater than mu naught. So if the sigma square is unknown, what we do is we find the sample variance. We find sample variance S square, and uh, the same way we have solved for the Z test, we will use the same way we'll do for the T test, except the fact that in place of sigma, I am now writing S, the sample standard deviation. So whenever we are using the sample standard deviation in place of population standard deviation, we solve it by the T test. Okay, so what happens in the t-test is, like, if you have let's say 100 samples, and if I solve this using the test statistic to be x bar, so alpha becomes probability x bar greater than c given mu equals mu naught, and this is probability z, one my not z, it is, okay, this is x bar minus mu naught divided by s upon root n greater than c minus mu naught upon s upon root n. And this term here, in place of we using the population standard deviation sigma, we are using the sample standard deviation s, and this becomes the t distribution with the degree of freedom 99. So 99 is nothing but n minus 1, total number of samples minus 1. So this is equivalent to 1 minus ft 99 of c minus mu naught upon s upon root n. So this value will be always provided to you in the problem. So what happens is, once your sample size is very big, okay, in that case, the conclusion that both the Z test and the T test will give is the same. So if you look at, like, if any of the number of sample is large and still you have to do the T test because your population standard deviation is not known, there also you can use the Z test approach and you can solve the problem. It will almost come out to be same. The conclusion will be same. So that you can just write out, not for the small sample, for the large sample size. This will work. So this was the right tail test. Similarly, we can do for the left tail test and the two-sided t-test, right? There's no major difference between the t-test and the z-test, except the fact that here we are using the sample standard deviation and not the population standard deviation. Any doubt in t-test? Any doubt here?
No, ma'am.
Okay. So the next is the chi-square test. The next is chi-square test. And this test is for variance. This is the test for variance. So all this Z test that we have seen, Z test, T test, and this chi-square test, we have seen this for one sample. So there is a two sample Z test also. There is a two sample T test also that we haven't studied in this course. And there is a two sample test for variance also, that is called as F test. So we'll look at the chi-square test and F test. So chi-square test is whenever we want to test for variance, right? Again, we have some samples x1 to xn, that is IID, normal with mean mu, variance sigma square, and I want to test my variance or standard, let's say standard deviation. So the null hypothesis is H naught is given as mu equals, sigma equals some sigma naught, and alternative hypothesis is for right tail test, it is sigma greater than sigma naught. And for the chi-square test, we consider our test statistic that is T as n minus 1 S square upon sigma square. What is S here? It is the sample variance. So whatever sample you have, you calculate the variance, and this is a T. And for the right tail test, the test become you reject H naught if S square is greater than C square. Okay. So given your H naught is true, that is sigma equals sigma naught, I say that n minus 1 S square upon sigma naught square resembles the chi-square distribution with n minus 1 degree of freedom. So this value will always be given to you in the paper. Always in the problem, this value will be given to you. And the process of finding the alpha and beta is again the same. So if I have to find the type 1 error, it is again probability that you reject your H naught if S square is greater than C square. So reject H naught if S square is greater than C square, given mu naught is true, that is H naught is true, that is sigma equals sigma naught. And this is same as probability. Now, given this H naught is true, this n minus 1, this test statistic, that is n minus 1 S square upon sigma naught square, which is greater than C square n minus 1 upon sigma naught square. This becomes the chi-square with n minus 1 degree of freedom. And we can write this as 1 minus F chi-square n minus 1 of C square n minus 1 of sigma naught square. So if you see, it's the same process, like whatever test it is, like even though it was a T test, again the process of finding this finding the alpha beta, it is same. Like you first define your null hypothesis, you define your alternative hypothesis, you decide your test statistic. So in case of chi-square test, the test statistic that you take is n minus 1 S square upon sigma square, because this becomes your chi-square with n minus 1 degree of freedom, and that value we can get very easily. So this is the test that we take, and we say for the right tail test that we are rejecting our H naught if S square is greater than C square, and you try to bring this S square in the form of n minus 1 S square by sigma naught square, and just calculate it. It's the same process. So there is no major difference. If it is a left tail test, we will say it is again S square. We will say reject H naught if S square is less than C square, and the process is still the same.
And same concept for beta also, right? That
Same
is what you
concept
said.
for beta also.
Beta
Yes.
also 1 minus, okay, power, okay.
Yeah. So this is the test of variance for one sample. Now, if I have to find, if I have to test for variance for two samples, so test for variance for two samples, we have something called F test. So in that case, we have two samples, let's say x1, x2 up to xn, that resembles some normal distribution. With mean mu1 and variance sigma 1 square. You have y1 up to yn in some normal distribution with mean mu2 and variance sigma 2 square. The null hypothesis we take is sigma 1 or sigma 1 square equals to sigma 2 square, and alternative hypothesis we take is sigma 1 square greater than sigma 2 square. In this case, for the F test, we take our test statistic, that is T, as S x square or S1 square divided by S2 square. So how do we decide this test statistic? Like we always take the one sample variance divided by the other sample variance, but how do we take it? So if I have a right tail test, so in this case we have a right tail test. So if I write this, I will say sigma 1 square upon sigma 2 square should be greater than 1. So I will write our T to be S1 square by S2 square. Okay. And the test I will say is you reject your H0 if T, that is S1 square by S2 square, is greater than some 1 plus CR. So what is this 1 plus CR? So in case of F distribution, you have a graph something like this. And the peak that we get is at 1. So we want this sigma 1 square, that is S1 square upon S2 square, to be greater than 1. So I take some CR and I say this S1 square upon S2 square should be greater than 1 plus CR. So this becomes my rejection reason. But in case I have a left tail test, it means if I have my HA to be sigma 1 square less than sigma 2 square, then in that case, I take my test statistic to be sigma 1, yeah. Okay, so we take our T test statistic value to be S2 square, or let's say I can just write S1 square by S2 square to be less than 1, right? So for the less than 1, we subtract this CL here. So 1 minus CL. Okay. So this is our rejection reason in case of the left tail test. The test become reject H0 if T is less than 1 minus CL. So if in place of S1 square by S2 square, if you would have taken S2 square upon S1 square, then you would have to check S2 whether S2 square by S1 square is greater than 1 plus CR or not. So that can always be changed. So better you stick with this one to avoid the confusion. So this is the right tail test. This is left tail test. And in case of two-sided t-test, what we do is we do alpha by 2. So this area and this area, they both combined should be alpha, and this should be alpha by 2 and this should be alpha by 2. So if I have to check for two-sided test, what we do is we take alpha by 2 and I say probability that I reject my H naught, given H naught is true. And when am I rejecting this H naught? So you can take any one of them. So probability, like let's say T less than 1 minus CL, given H naught is true, or probability T greater than 1 plus CR, given H naught is true. This both becomes alpha by 2. So anything you take, you will get the same answer. And in case of F distribution, what happens is your S1 square by S2 square. This becomes your F distribution with the degree of freedom. So the number of samples in the first number of samples in the first sample, that is n1 minus 1, and in the second one, that is n2 minus 1. And again, we do the same process the way we have done for the t-test or the chi-square test or the z-test. So there is no major difference in how you come to the conclusion. You just have to identify your test statistic correctly. You have to identify your test and then just proceed. So all the tests, okay, there is 2 samples at test that is left. That also we can look at. And then if you want to know the problem from few of the tests, we can take that. Okay. So the next one is 2 sample Z test. So in case of 2 samples Z test, you have again 2 samples x1 to xn, that is IIT normal with mean mu1 and variance sigma 1 square, and you have another sample that is y1 to, let's say, ym, that is IID in normal, mean mu2 and variance sigma 2 square. So what do we take our test statistic to be as test statistic T to be x bar minus y bar or y bar minus x bar. And what is the null hypothesis? Null hypothesis is mu1 equals mu2, and alternative hypothesis to be mu1 not equals to mu2. And we define our test statistic to be x bar minus y bar or y bar minus x bar. And given your H naught is true, our test becomes normally distributed. So what is the mean of the T? So expected value of x bar minus y bar, this becomes 0. So given H naught is true, your mu1 minus mu2 is 0. So expected value of yes, hold on. Yeah. So given your H naught is true, it means mu1 minus mu2 equals 0. Your expected value of x bar minus y bar becomes 0, and variance of x bar minus y bar becomes variance of x bar plus variance of y bar, right? And what is variance of x bar? So variance of x bar is sigma 1 square by n plus sigma 2 square by m. Okay. So this is variance of x bar minus y bar. So the T becomes normal given H naught is true, given H naught, your T becomes normally distributed with mean mu and variance sigma 1 square by n plus sigma 2 square by m. So in case your both of the number of samples is same in both the samples, so you just, in place of m, you are going to take n. And again, the process is going to be same, like you have to find the alpha probability that you reject your H naught. given this t is greater than c, so is greater than c. So mod of t greater than c given h naught is true. And again, you try to convert this t into the normal 0, 1 and then just solve it. Any doubt in any of the tests? If it is there, you can ask me.
Nikita, is it possible to take one question for two sample Z test?
Yes.
I'm not very comfortable with the last step that you have just told. Mod of t, how do we
Yeah.
just solve that particular thing?
So first problem I will take is two sample Z test. Any other thing that you want me to explain? I will take one problem from two sample Z test. Can you tell me one more problem? One or two more problems? Okay, so let's see the two samples at test first. So I will take one problem from the practice assignment, okay? The first problem that you have in the practice assignment. So practice assignment, problem number one. The problem says you take a random sample of 40 fibers manufactured using process A. So there are two processes, A and B, to manufacture. And from the process A, you take a random sample of size 40, and from process B, you take a random sample of size uh, 60. It is given that using the process A, we have obtained the sample mean, that is x bar, as 16.7 and standard deviation of 0.5. Standard deviation is yes, 0.5. And in case of using B, you have the sample mean of 16.4 and the standard deviation to be 0.6. Now we have to identify what is the null and alternative hypothesis. What we want to check is test the hypothesis that the mean length of fiber manufactured using process A and B are the same. So we want to check whether the mean length of fibers that is being manufactured using both the processes is same or not. So what we will do is, in this case, our null hypothesis is mu1 equals mu2, and my alternative hypothesis is mu1 not equal to mu2. So once we have defined the null hypothesis and the alternative hypothesis, the second step that we decide is what is my test statistic. So in case of the two sample set test, we say my test statistic is either x bar minus y bar or y bar minus x bar. So let's say I'm taking the test statistic to be x bar minus y bar. Okay. And my test will be that we reject H naught if mod of t, if mod of t is greater than C. So why they are taking mod of t greater than C? If you go back and check the one sample two-sided test, right? Two-sided set test for one sample. There we had seen like why this test was. Let's go back there. Yeah. So this was for the two-sided test. So there also the test was reject H naught if mod of x bar minus mu was greater than C, correct? So why we had taken mod of x bar minus mu greater than C? Because we were interested in these both sided tail area, right? And these two combined becomes R alpha. Now, given my H naught is true, if my null hypothesis is mu1 equals mu2, so in that case, my mu becomes, the sample mean, like if the test statistic is x bar minus y bar, the expected value of x bar minus y bar becomes 0, right? So we just take our test statistic, like test is reject H naught if mod of t, that is mod of x bar minus y bar, is greater than C. Is it clear? Is it clear?
Yeah, I mean, mu1 equals mu2, and then you are saying expected value of x bar minus y bar equals 0.
Yeah, in this case, we had for the one sample test, we had seen the test, like when I had taken my test statistic to be x bar, and my test was reject H naught if mod of x bar minus mu is greater than C, right? So if I have two samples and my T is x bar minus y bar, then in that case the test becomes reject H, like given H naught is true, I mean reject H naught if mod of x bar minus y bar is greater than C.
Okay, fine. Yeah.
So even if you take let's say mu x minus mu y, this is like there's no issue, just fine. All right, so I am saying that I will reject my H naught if mod of test statistic is greater than C, right? Now, if I have to find my alpha, I will do probability mod of t greater than C. Given H naught is true, that means mu1 equals mu2, correct? So what is t? It is x bar minus y bar mod greater than C given mu1 equals mu2. It means this mu1 minus mu2 equals 0. Now, if I have to find the mean of x x bar minus y bar, it becomes 0. So mod of x bar minus y bar divided by the variance, right? So what is the variance? Variance is going to be sigma 1 square, that is 0.5 square by 40 plus 0.6 square by 60. So it becomes 0.5 square by 40 plus 6 square by 60. And this is greater than C upon the same thing. Sorry, this is under root. Okay. Whatever we have written here, this is going to be there. So this is again 2 times probability Z less than minus C upon under root of 0.5 square upon 40 plus 0.6 square upon 6. And this is 2 times instead of minus C upon this. Is it okay?
Yes, okay.
All right.
Yeah, thanks.
Anything else?
Ma'am, I had a conceptual doubt regarding alpha and beta.
Okay.
So in lecture, sir said that committing type 1 error is more serious than type 2 error.
Committing type 1 error is more serious than committing type 2 error. Okay.
Yeah, so I couldn't understand why this was so.
So type 1 error is even though your
H is true,
H hat is true, we are rejecting my null hypothesis. And H is like the alternative is true, and then you are accepting your null hypothesis.
is beta, yeah.
Yeah. Why is it so? Okay. Okay, just can you post this question on Discourse? I will just have a look at it properly and then I can answer.
Surely, ma'am.
You can just start me there.
Yeah, of course.
Yeah, thank you. Anything else? So all of you have started week 11, right?
Yeah, yes, ma'am.
Okay. Yeah, please like study properly week estimation part and hypothesis testing. This is going to cover the maximum number of problems. So please do it properly. Hypothesis testing, once you understand the concept, everything follows the same. Everything we can solve using the same method. You just have to be a little careful and know what test you have to use. Any other doubt? Any other doubt you have? If there is no doubt, should we close the session then? I see there are around 58 participants. Anybody? Okay, so we can leave the session now. So we can drop off. Thank you for joining in. Like please study properly. Yeah.
Thank you, ma'am.
Yeah, thank you.
Thank you.
Yeah, thank you.